Hello friends, I welcome you in lecture number 10 on series solutions of differential equations. From last 2 or 3 lectures we are discussing Legendre polynomials. In previous lecture we have seen general formula for Legendre polynomials, and using that formula we had derived these first 5 Legendre polynomials, and sometimes we will require these expressions for some questions of this type. Sometimes they ask you to express a given polynomial in terms of Legendre polynomials. So today we are going to discuss that how to express given polynomial in terms of Legendre polynomials, and we discuss this question related to this, which was asked in GTU Winter 2021 exam. Here we are given this polynomial of second degree 2 minus 3x plus 4x square, and we have to express this polynomial in terms of Legendre polynomials. So first thing you have to observe is what is degree of given polynomial. So this is second degree polynomial, so we will require Legendre polynomials of degree 0, 1 and 2. We will write down this expression or given polynomial 2 minus 3x plus 4x square in this way: some constant into polynomial Legendre polynomial of degree 0 plus some another constant into polynomial of degree 1 plus some another constant into Legendre polynomial of degree 2. So how to decide these constants a0, a1 and a2? So first thing required is we must recall, or we must remember the expressions for p0, p1 and p2, and if we are not able to remember, we can derive them using that formula for Legendre polynomials. So first I am writing the first 3 Legendre polynomials. So the Legendre polynomials which are required for this question, Legendre polynomials of degree n equal to 0, 1 and 2 are, we know that Legendre polynomial of degree 0 is simply 1 constant polynomial. Legendre polynomial of degree 1 is also easy to remember, and Legendre polynomial of degree 2 is 3x square minus 1 divided by 2. Let me check this. I have written these expressions here. P0x is 1, P1x is x, and P2x is 3x square minus 1 divided by 2. So it is not hard to remember these 3 polynomials. If you forgot these expressions for Legendre polynomials, then you can use this formula which we have discussed in lecture number 9 to derive Legendre polynomial of degree n: minus 1 raised to r 2n minus 2r factorial 2 raised to n into r factorial n minus r factorial n minus 2r factorial times x raised to n minus 2r. Using this formula you can write down Legendre polynomial of degree n. So if you forgot, you can put particular values of n here, and you can write your required Legendre polynomial of required degree. Here our polynomial is of degree 2, so we require Legendre polynomials up to degree 2. Now in the next step we will write expressions for this. You can write 2 minus 3x plus 4x square. This I can write as 2 into 1 minus 3 into x plus 4 into x square. Now I know that this 1 can be replaced by p0x, and this x can be replaced by p1x, and I have to obtain the expression for x square in terms of p2x. So that I can obtain from this expression for p2x. I can find out x square using this equation for p2x. p2x is given by 3x square minus 1 by 2. Therefore 3x square minus 1 can be written as 2 times p2x. Therefore I get 3x square equal to 1 plus 2 times p2x, and therefore x square equal to 1 plus 2 times p2x divided by 3. So we will replace x square by this expression which is in terms of p2x, and we will replace x by p1x, 1 by p0x. So in the next step we try to express given polynomial in terms of p0, p1 and p2. Given polynomial is 2 minus 3x plus 4x square. This I can write as 2 into 1, and 1 is nothing but p0x minus 3x is nothing but p1x, and plus 4 times x square is replaced by 1 plus 2 times p2 of x divided by 3. Now we try to simplify all these things. This is equal to 2 times p0x. Let me write here 2 times p0x minus 3 times p1x plus 4 by 3 into 1 plus 4 into 2, that is 8 by 3 into p2x, and this is finally 4 by 3 plus 2 times p0x minus 3 times p1x plus 8 by 3 p2. Okay, fine. So we can see all these terms are containing Legendre polynomial of degree 0, 1 and 2, but this term is independent of Legendre polynomial. So we can write 4 by 3 as 4 by 3 into 1, and 1 can be replaced by Legendre polynomial of degree 0. In the next step I write 4 by 3 as 4 by 3 into p0x, because p0x is 1, plus 2 times p0x minus 3 times p1x plus 8 by 3 times p2x, and here I can take p0x common, and I am left with 4 by 3 plus 2 into p0x minus 3 times p1x plus 8 by 3 times p2x, and this I can rewrite as 4 plus 3 into 2, that is 6, and 4 plus 6 is 10. 10 by 3 times p0x minus 3 times p1x plus 8 by 3 times p2x. Now each term contains Legendre polynomial of some degree. Therefore this is the expression for 2 minus 3x plus 4x square. Our given polynomial is 2 minus 3x plus 4x square, that we have expressed in terms of Legendre polynomials. 10 by 3 p0x minus 3 times p1x plus 8 by 3 times p2x. So this is our answer. We have expressed given polynomial of degree 2 in terms of Legendre polynomials of degree 0, 1 and 2. And be careful here, if you have only constant, then you can write that constant as 4 by 3 into 1 and replace 1 by p0x. So answer must contain, each term in your answer must contain Legendre polynomial of some degree. So let's summarize this. We are asked to express this polynomial in terms of Legendre polynomial, and here we can see this is of degree 2, and we have written this polynomial as 2 into 1 minus 3 into x plus 4 into x square, and we can replace 1 by p0x, x by p1x, and we have to find the expression for x square that we obtain using the formula for p2x. From this formula we find out expression for x square in terms of this Legendre polynomial, and then we substitute all these values here, and at one place we encounter one constant term that we replace by 4 by 3 into 1, and 1 we replace by 4 by 3 into p0x. So it is easy to express given polynomial in terms of Legendre polynomials in this way. So this is all about this session. I hope you like it. Thanks for watching.